Welcome back to the Explainer. Today, we're going to peek under the hood of how software actually makes decisions. We'll be using Python for our examples, but honestly, these fundamental concepts, they are the bedrock of nearly every application you use. So let's just start with a big question. Ever wonder how the apps on your phone just seem so smart? How do they know exactly when to pop up a notification, or map out the quickest route, or even queue up your favorite song? Well, spoiler alert, it's not magic. It's something far more elegant, actually. It's the power to make a rapid-fire series of simple, logical choices. And to show you exactly how this all clicks together, we're going to build a simple food ordering program right here, from the ground up, one step at a time. All right, let's dive in. Okay, first things first. Our program needs to make a fundamental choice. Is the user hungry or not? This is its very first decision point. So to represent a state like hungry or not hungry, programmers use this special data type called a Boolean. And it's super simple. It can only ever be one of two things, true or false. Just think of it like a light switch, right? It's either on or it's off. There is no in between. We use that Boolean with something called an if-else statement, which basically creates two distinct paths. You can see it right here. If our isHungry variable is true, the program follows the path on the left and says, let's order food. But if it's false, it takes the else path on the right. It is literally a fork in the road for our code. And that's really it. That's how we translate a simple, real-world decision into a structure the computer can actually understand and act on. We've just given our program its first little piece of intelligence, the ability to react differently based on a specific condition. But a single condition is rarely enough, right? Real-world decisions are usually way more complex. So how do we make our program even smarter? Let's find out. We can layer our logic with what are called operators. Now, the AND operator, think of it as a really tough bouncer at a club. Every single condition connected by AND must be true to get past. So in this case, the user must be both hungry and a burger lover. No exceptions. The OR operator, on the other hand, is much more accommodating. It only needs one condition to be true to open the gate. So if the user loves burgers or they love pizza, the condition passes. Liking both isn't necessary, just one is totally fine. So how does Python handle all this when we combine them? Well, just like in math class, it's all about the order of operations. You can see in step 1, Python tackles what's inside the parentheses first. So if the user likes burgers but not pizza, the OR makes that whole section true. Then, in step 2, Python checks the rest. Is the user hungry, and is the result from the parentheses true? If both are true, then boom, the final outcome is true, and the food is on its way. Okay, so our program can think. That's awesome. But how does it remember more than one thing at a time? I mean, what if we need to handle a full menu or a long shopping list? Creating a separate variable for every single item, like you see on the left, oh man, that would be a total nightmare. It's inefficient and just a headache to manage. But on the right, that's the Python way. A list lets us bundle all those related items into a single, organized variable. So much cleaner. So what exactly is a list? Well, it's just an ordered container. The items have a specific sequence, we can change the contents on the fly, and it's all defined with those simple square brackets. Lists are one of the most versatile and essential tools in programming. All right, now that we have a list, we need some tools to actually work with it. How do we get items out, put new ones in, or get rid of things we don't need anymore? Let's explore the essential methods for managing our list. To grab a specific item, we use its position, or index. And here's the golden rule you have to remember. In programming, we almost always start counting from 0. So the very first item is at index 0, the second at index 1, and so on. I know it might feel a little weird at first, but trust me, it'll become second nature really fast. This table is a fantastic little cheat sheet. .append is your go-to for just tagging an item onto the end of the list. .insert gives you more control, letting you place an item at a specific spot. And when it comes to removing items, you've got two options. .pop yanks an item out based on its index number, while .remove hunts for an item by its value, like eggs, and removes the first one it finds. So in just the last few minutes, you've actually acquired some seriously powerful new programming skills. Let's do a quick recap of these new superpowers you've just unlocked. You can now literally control the very path your program takes with if-else. You can build complex, layered rules using AND or OR, and you can efficiently store, organize, and manage entire groups of data with lists. And look, this isn't just some abstract theory. These two concepts, logic and lists, are the absolute fundamentals. They are the core building blocks behind the dynamic, responsive, and intelligent apps you use every single day. Which leaves us with one final thought. You now know the basics of how to make code think and remember. With these tools in your hands, the only real question is, what are you going to build first?